Hello, everybody. Welcome back. We're going to be taking notes on exponential functions today. So, in your notebook, make sure you date whatever today's date is, and then write the title of the notes today, which is exponential functions. We're going to be going back and forth between some glue-ins and some and writing in our notes today. So just be aware of that. Make sure you have your packet out or have whatever glue-ins you have access to out. All right, so we're going to start with defining what is an exponential function. So an exponential function is in the form of a times b to the x. Now this is very important. The x has to be in the exponent. It cannot be down here in a. It cannot be down here in b. Okay. A, so the number in front of the base, represents the y-intercept. And remember, if there's no number written, it's just a 1. Okay, B is the base of my exponent, and that is my multiplier. That means that is what I'm multiplying by every single time. So really what we're looking at here in an exponential function is if you are multiplying, and we're going to say or dividing, and we'll talk about that later on. Okay, so if you are multiplying or dividing by the same number every time. So what I mean by that is if you're going like times 2, times 2, times 2, times 2, right? Or divided by 4, divided by 4, divided by 4. So every single time you're multiplying by the same number or dividing by the same number every time, then it is an exponential function. So you need to make sure that that x is up here, and I'll finish that. Oops, that was bad. There we go. That x is up here in the exponent. Okay, so we're going to look at a couple examples here of whether or not something is an exponential function or not. Okay, so let's look here. You should have this access to these notes, either in your packet or in some other way. So what we're going to do here is we are going to go down and we're going to, let me scroll down. Okay, we're going to determine whether or not these in example 1 are functions or not, or exponential functions, excuse me. Okay. And so what we're going to do is we're just going to kind of go through, and I want you guys to try this. So you're going to hit pause on the video and try it. And I want you to see if you can determine whether or not this is an exponential function or not. So just kind of circle yes or no, and then we can talk about the ones that are not. Okay, so here I've gone through, check your answers here. Notice that anytime that I have an x in the exponent, it is not, or it is an exponential function. The x cannot be in the base. So like here on B, see how it's x squared? The x is a base, not a exponent. So this is not, and this is actually a quadratic. Okay, so that's a quadratic function instead, right? Because x squared makes a parabola. For D, it's no, because even though the x is in the exponent, it's also down here in the base. Okay, so you cannot also have x in the base. Oops, have. So that is the reason why D is not. And then H, okay, here x is not an exponent, it's down here with the 2, and this is a linear function, that is a straight line. So again, anytime that you have that x in the exponent, you're looking at an exponential function. So what we're going to do is we're going to look at the graphs of a exponential function. And what makes it hard, we're going to go back into our notebook here. What makes the graphs hard is that it depends on the base, okay? So the graph of y is equal to a times b to the x changes depending on b. So that's what makes it a little bit more difficult. But what we're going to do is we're going to go through an example, and then I'm going to give you kind of like the parent, quote unquote, parent graph points that you can always use to help you graph the exponential function. So again, in your packet, you should have hopefully some blank graphs. You only need one of these, so do not rip out the whole page. Just cut out, like one of these, okay, and glue it into your notebook. And you can kind of glue it into your notebook over here. And of course, I don't have one myself, so, right, so you kind of glue it into your notebook right there. So if I wanted to graph, for example, y is equal to 3 to the x. B is 3, A is 1, right? So B is my base, so that's 3, and then A, there's no number written out here, so that A is just 1. So we can make an XY table. Wasn't very straight, but that's okay. And kind of go down the list, right? If I plug in 0 for x, I'm going to do it over here. That gets me 3 to the 0. Well, anything to the 0 is just 1. So that gives me a point of 0, 1. If I plug in 1, it gets me 3 to the 1. Well, 3 to the 1 is just 3. If I plug in 2, it gets me 3 squared, which is 9. All right, I can keep going. If I plug in 3, it'll get me 3 to the third, which is 27, which is very unlikely it will fit on the graph, right? What about if I plug in -1? 3 to the -1. We have to remember our exponent rules. I cannot have a -1 exponent. So this becomes 1 over 3 to the +1. Well, 3 to the +1 is just 3, so I get 1 over 3. So I get 1/3. Okay, what about -2? 3 to the -2. Again, I can't have a negative exponent, so it becomes 1 over 3 squared, right? The 2 becomes a positive when I move it to the bottom. And 3 squared is 9, so I get 1/9. And I could keep going, but -3 would be 1 over 27, and that doesn't sound like something I'm very excited to graph. So this kind of gives me my points to then graph it. I'm going to go ahead and graph it. So go ahead and plot that on your graph that you glued in. Okay. I don't have one of those graphs, so I'm just going to show you how to do it on here. So don't actually do it on this sheet. Graph it on that graph that you glued in. But just to show you, I have 0, 1, 1, 3, 2, 9, which is up there somewhere, -1, 1/3, -2. And what actually happens is that there's an asymptote here. Okay? Think about it. If I'm going to the left, I'm dividing by 3. Dividing, right? If I'm going this way, I'm dividing by 3, dividing by 3, dividing by 3. If I keep dividing by 3, will I ever get to 0? And if we really think about it, the answer is no. The only way I can get to 0 is if I do 0 divided by something, right? And so because I never get to 0, it'll just keep getting smaller, 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 and I get infinitely close to 0, but I can never get to 0. Okay, so my graph is doing something like this, more or less. And so the thing to notice is that there's an asymptote on the x-axis. Okay, so there's an asymptote on the x-axis. So what I want to show you now is kind of like the general, how do we graph um, y is equal to b to the x, right? We're going to go ahead and just say that a is 1 here. Okay, so I want to show you the points. First of all, there's an asymptote, right? We just wrote that on the x-axis. As long as that graph has not been moved up or down, there's an asymptote on the x-axis. And I'm going to have points at 0, 1. That will always be a point in this graph, no matter what b is. Then I'm going to have a point at 1, b. So if b is 3, it would be 1, 3. If b is 4, it'd be 1, 4, right? Then I'm going to have a point at 2, b squared. So, if b is 3, it'll be 2, 9. If b is 4, it'll be 2, 16. You can continue this and say 3, b cubed. Most of the time, that will not fit on the graph. And then we can go the other way. We can say negative 1, 1 over b. And then we can also say negative 2, 1 over b squared. So again, depending on what b is, right? But this kind of is the general idea of how to graph an exponential function. So what I want you to do now is we're going to go back to our little note sheet in our packet. I know we're going back and forth a lot. And I want you guys to do example 2. So it says graph each of the following and find the domain and range for each function. So use those points that I just gave you, okay, and see if you can graph f of x equals 2 to the x. See if you can graph g of x equals 1/2 to the x. So go ahead, pause the video, use those points I just gave you, give it a try, and then when you're ready to review it, you can hit play and we'll go over it. Okay, so let's go over these. Hopefully you gave it a shot. I'm going to do these in 2 different colors since we're going to graph them both on the same graph, okay? So f of x equals 2 to the x. So I know that I'm going to have a point because a is 1, right? So a equals 1. B here, my base is 2. So I know I'm going to have a point at 0, 1 right here. Okay? Then I'm going to have a point at 1, b. Well, b is 2. So 1, b. So 1, 2. Then I'm going to have a point at 2, b squared. Well, 2 squared is 4. So 2, 4. Then I'm going to have a point at 3, b cubed. 2 cubed is 8. Right? 2 times 2 times 2 is 8. Okay, then I'm going to have a point at negative 1, 1 over b. Well, b is 2. So negative 1, 1/2 is a point. And then I'm also going to have a point at negative 2, 1 over b squared. B squared is 4, so 1/4. And I could keep going and do 1/8, but it just seems like we don't really need it. We can kind of see what this graph looks like now. So I connect it knowing that there's an asymptote on the x-axis. So the graph never crosses the x-axis. Okay, so now let's find the domain and range here. How far to the left does this graph go? Well, there's an arrow, so it keeps going on and on and on, so it goes on to negative infinity. And then how far to the right does it go? Well, again, it has an arrow, so it keeps going over, right? So it goes up to positive infinity. And we always use parentheses at infinity. So you can write it like that, or you can write it like this, or you can say x is in the set of all real numbers. All three of those options work. Just pick one. You don't have to write down all three. Just pick the one that you like, or pick the one that you've been using. Okay, my range, what's the lowest that this graph goes? Well, it never, ever, ever crosses 0. So the lowest I can get is 0, but it doesn't actually ever get to 0, so it's a parenthesis at 0. And then what's the highest that this graph goes? Well, this graph keeps going up and up and up all the way to infinity. So again, you can write it like that, or you can write it like this. Either way. Okay, now let's go ahead and look at g of x. If you haven't tried it yet, this would be a good time to pause it and try it. And we're going to do g of x in a different color. Okay, so now, how did that happen? Oh, I'm all dark. Okay, so now what we're going to do is we're going to look at 1/2 to the x. So again, it's going to be the same thing. My a is 1, right? What's going on? My a, there we go, is 1. And my b is 1/2. Okay, so I'm going to go through, and since a is 1, I can say that 0, 1 is going to be a point. I can also say that 1 comma b is a point, so it'll be 1 comma 1/2 there. 2 comma b squared. Okay, so 1/2 squared is the same thing as 1 squared over 2 squared, which is 1 over 4. Okay, so 2 comma 1/4 is the point. And then I could keep going and get 1/8, but I'm not going to. So let's go the opposite way now. -1 comma. My pen is all jumpy. My screen's all dark. Okay, so it's 1 over 1/2, right, at -1. So watch what happens when I write it the other way. 1 divided by 1/2. If I make the 1 a fraction, now I have dividing fractions. So it's copy, dot, right, flip. So I get 2. So -1 comma 2 is a point. At -2, it's 1 over b squared. So now let's get rid of this. I know that b squared is 1/4. So it'll be 1 over 1/4. And I do the same thing. 1 divided by 1/4. And I copy, dot, flip. And I get 4. So it's -2 comma 4. And I could keep going. -3 would be 1 over b to the third, which gives me 8. So it's really just the same points up here, just flipped over the y-axis. Oh, I didn't graph this one. 2, 4, and then -3, 8. So it's the same graph as the red one. It's just, oh boy, sorry. It's just flipped over the x-axis. So again here then, what is the domain? How far to the left I go? I go all the way to -infinity. And how far to the right? Positive infinity. My pen does not like me right now. And then the range, how far down do I go? Well, I can't go any further up than 0 or further down than 0, and I go all the way up to infinity. So the domain and range actually are the same regardless. Domain will always be negative infinity to infinity, and then your range will only change if you shift the graph up and down. Okay, so the last thing that we're going to talk about here is what happened, what did we notice that happened when b was greater than 1, like when we graphed the 2 to the x? And what happened, what did we notice that happened when b was less than 1 or between 1 and 0, like when we graphed the 1/2 to the x? So when b was greater than 1, that was like the one that we did that was like f of x is equal to 2 to the x. Or we also graphed ourselves y equals 3 to the x, right? Anything where b is greater than 1. So what's going to happen there is the graph increases from left to right. My pen doesn't want to work today. That's okay. Okay, so the graph is going to increase from left to right. So if we look at that graph of 3 to the x, it's going up. If we look at that graph of 2 to the x, it's going up from left to right. Okay, so I guess here we can write those examples. We don't have to write on the outside like I did. So that f of x is equal to 2 to the x will be increasing from left to right. If I have y is equal to 5 times 3 to the x, it's going to be increasing from left to right. A is 5 and then b is 3, so b is greater than 1. If I have something like negative 1/2 4 to the x, it's going to be increasing from left to right. Okay. B is greater than 1. What about if I do 0 is less than b is less than 1? So this is like whenever you have a fraction that's less than 1, okay? So here you're going to get that the graph decreases from left to right. It looks like I'm writing with like a chisel or something. From left to right. Okay, so this was that 1/2 x that we did, right? That was on the previous page, so that f of x equals 1/2 x, or 1/3 or 1/4 or whatever, right? Y, you could say y is equal to 3 times 1/4 to the x. We can say f of x equal to negative 2 times 1/3 x, right? So this is when you're going to have fractions that are less than 1 in as your base, right? So inside the parentheses or as your base. Okay, the domain of exponential functions, we just talked about it. The domain is always going to be negative infinity to infinity. Okay, and then the range is always going to be 0, oh boy, 0 to infinity. But we're going to make a little note here, and I'm going to say unless graph is moved. Holy moly, you guys, you can't even read my handwriting. Is moved not left or right. Sorry, I'm getting distracted by my bad handwriting. So unless the graph is moved up or down. It's funny, it like won't let me make a curve. Everything is like a straight line. Okay, so unless the graph is moved up or down, that will change the range. But for the most part, it's going to be 0 to infinity, and then you adjust it if it's been moved up or down. And then the last thing that we're going to look at here in these 4 little boxes are some things that are going to be really helpful for us, some tips and tricks, right? So I want to just point out that multiplying by 1 over x, right? So if I have like 1/3 or 1/2 or whatever, right, is the same as dividing by x. So let me show you what I mean by that. So if I have the equation, let's say y is equal to 3 times 1/2 x. That tells me that I am multiplying by 1/2 every time, right? So multiplying by 0.5, multiplying by 0.5, or multiplying by 1/2. So multiplying by 1/2. Sometimes it's like kind of hard to do. You're like, okay, what's -1 times, or right, like 1 over 1/2 or whatever. Like multiplying by 1/2 sometimes isn't the easiest. So we can also think of this as the same thing as dividing by 2. So if I'm like, okay, I'm multiplying by 1/2 every time, I can also think of it, okay, I'm dividing by 2 every time. And that makes it a little bit easier to think about, okay? Same thing, what if I have like f of x equals 2 times 1/3 of x, right? So here I'm like, okay, I'm multiplying by 1/3 every time. That's kind of hard to think about. Multiplying by 1/3. Okay, so you're like, okay, I multiply by 1/3 to get my next point, and then multiply by 1/3 to get my next point, and my next point, and my next point. Or you can just think of it as, hey, I'm dividing by 3 every time. Sometimes it's helpful to think about it as multiplying, but sometimes it's helpful for us to think about it as dividing. And then like you also can think about it the other way. Like what if I have like y equals 4 times 2 to the x, right? Here I'm multiplying by 2. Holy moly. Multiplying by 2 every single time to go to the right. But then if I want to go to the left, what do I do? Then I can think of it as like dividing by 1/2. So you can go either way. Sorry that my screen got all jumpy and now it's not working. Okay, so you can go back and forth between those. So I didn't even spell dividing wrong. I love that. That's funny. Whatever way is helpful for the problem that you are doing. Okay, that's the way that you should think about it. And so we have some practice on this. That's it for notes, you guys. And then now you guys just have some practice on how to graph these functions. So if you need any help at all, just make sure that you reach out and make sure that you're asking for help if you need it. And we'll see you guys soon.